Hello, this is Mrs. Hanson, and this is rare. I am doing this video in my car. Why? Because it was really important to me that even though I'm not there today, that I am with you because I wanted to make sure you got some feedback on these your turn problems that are on page, shall we say, 26.5. And I would love it if you pulled that out of your binder and let's just take a look at it as if I'm there in front of the classroom with you. Okay? So, you guys, this graphic at the bottom, I don't know if you looked at it, but I think it could be really helpful. So you guys, with salt, it's really not that complicated. With a salt, you have a cation and you have an anion, right? Okay, and that's the first step. You got to break it up into its ions. Okay, if you look at the cation, if you look at the positive part, there's only two choices. Okay, it's either acidic, okay, these two choices, or it's neutral. Those are the only choices. It's either acidic or it's neutral. Okay, now from there, there's two more details. The cation's either a metal or it's not a metal. Okay, so let's talk about the metals first. It's pretty simple. If it's a low charge big metal, it's neutral. So that includes your alkali metals, and then we threw in barium 2+ and strontium 2+ because they're big. Okay, and coincidentally, these match up with the metals that come from strong bases. Okay, so you got your alkali metals, barium, strontium. Okay, low charge big metals. And then the acidic ones, these are high charged small metals, okay? Basically because they got a stronger charge spread over a smaller spot, a smaller space, so they do their job really well, okay? So high charged small metals, acidic. Low charged big metals, neutral. Done. It's that easy. Okay, now if it's not a metal, then it's going to be a bunch of nonmetals, and I'll tell you what, the only option is that it will be a conjugate acid, okay, because the cation's acidic of a weak base, okay? And the classic example is something that does contain nitrogen, hydrogen usually, and some other organic things, right? So let's say this is not a metal, right? So if you put it with water, this acid's going to do what acids do. It's going to donate the H, okay? Here's my, here's the bases remade, right? Because it donated that H, and there's my hydronium, okay? So when that guy dissolves in water, it makes the solution acidic. So those are your only two choices, okay? If it's either a metal, these guys are neutral, these guys are acidic, highly charged, or if it's not a metal, it has to be a conjugate acid, okay, from a weak base, and a conjugate acid makes the solution acidic, right? So that makes sense. Now with the anion, I think it's even easier. So with the anion, you really only have two choices. It's either neutral, okay, or it's basic, okay? Neutral, guess what? There's 6 choices because it's the conjugate bases, right? Because it's bases, we're talking about anions, bases from the strong acids, okay? So there's 6 strong acids, so guess what? There's 6 conjugate bases from strong acids. So these guys, they do not hydrolyze, okay? And as you see from the example, if you're coming from a strong acid, that means you're a terrible base. So Cl- plus water, it's supposed to act like a base and accept an H. Well, it doesn't want to make HCl, okay? So it's a terrible base. So this is just going to break up. So this reaction does not happen, okay? If you're any other conjugate base, then you must be from a weak acid. So guess what? If you're coming from a weak acid, you must be a pretty decent base. So F- actually can accept an H from water because HF does like to be formed, and it makes OH-. Okay, so if you're not that great of an acid, you're a weak acid, then you're a pretty good base. Do you guys see how that works? Okay, so with that in mind, it's that simple. Okay, so if you're a cation, you're either acidic or neutral. If you're an anion, you're either basic or neutral. And that's it. It's that simple. So now when we look at these examples, like NaBr, okay, Na, well, that's one of the alkali metals, so that's going to be neutral. Okay, but I do want to remind you the reason why, okay? So keep in mind, in the video, we talked about how metals, how ions get hydrated. So Na+ does get hydrated. It's going to attract waters. Okay, so when it attracts water, the question is if you only have a measly +1 charge, and that charge is spread over a big space, is this attraction strong or weak? Hopefully you said weak. So if that attraction's weak, that Na+ is not really pulling on the O that hard. So therefore, this bond doesn't get weakened and that H doesn't come off. So that's why Na+ does not hydrolyze. Okay, so that's neutral. Now what about Br-? Okay, so we'll say neutral and why. low charged metal, right? Now what about Br minus? Okay, Br minus, well, it's an anion, so it's either neutral or basic. It's a conjugate base from a strong acid or a weak acid. So this guy, of course, is a conjugate base of a strong acid, so it's not going to hydrolyze. So this guy is neutral overall. What about this guy? So you first, and I didn't say this here, but I'm going to say it here, you got to break it into its ions. Copper 2 plus, NO3 minus. You got to look at them individually. So nitrate, well, it's an anion, so it's a conjugate base. Is it from a strong acid or a weak acid? Okay, and of course that's from a strong acid, so that's going to be neutral. Okay, copper 2 plus. All right, so it's got a 2 plus charge. It's pretty small, so it's probably going to hydrolyze. Not as much as maybe aluminum plus 3, but it is going to hydrolyze. So copper 2 plus having a bigger charge and being smaller, it's going to get hydrated. Will copper 2 plus be able to pull on that oxygen, pull that oxygen towards itself? Yes. And when it does, what happens to this H? It can come off. Okay? So just comparing these two, not a big enough charge to attract the O well. Copper 2 plus does have a big enough charge and it can attract the O really well. Okay, and when it attracts that O, this bond weakens and the H can come off. Okay, so that's going to be a high charge metal. Okay, and that's going to make this guy overall acidic. Okay, good. Oh man, I love this one. Like, what the heck is that? Like, clo, right? It's so many letters. So I'll give you a tip. Usually salts are a metal and a non-metal. So when you see the metal, you know that's the first part, and you know the rest is the anion. Well, this one's kind of tricky since there's no metal, right? So then I would do it the opposite way. I would look at the back end and see if you recognize something. So I'm like, oh, well, I know what this is. So that's ClO4 minus. And then that means the whole rest of this guy must be the cation. So if this is the anion, this whole big boy must be the cation. You see? So now you can break it up. Well, ClO4 minus, well, let's see. What is it? It's conjugate base of what kind of acid? Oh, of a strong acid, because it comes from the perchloric acid. Okay, so that's going to be neutral. And then what about this guy? Well, it's not a metal. Okay, so the only other choice is this must be a conjugate acid, of course, of a weak base. Okay, so therefore that's going to make the solution. So this guy as well is going to be acidic. Now, in terms of writing out that reaction, remember, you just look at the ion that's actually hydrolyzing. So I'm going to ignore all this. Okay, and this guy's, it's acting as a conjugate acid, right? So it's going to do what acids do. And it's going to break off that H plus, this guy right here. And then what's left? C5H5N. Okay, so there you go. So it produced H plus in solution. So there's your acid. Okay, and finally, the last one. LiNO2, okay, so this is Li plus, NO2 minus. All right, what do we see? So Li, low charge metal. Bam! Okay, so that's neutral. NO2 minus, well, it's a conjugate base. Conjugate base of, well, NO2 is not from one of the big six, so that's of a weak acid. So that guy's going to make the solution basic. Okay? So there you go. I hope that helped a little bit. At this time, I want you guys to go on to page 27-28, where you're going to dig really deep into how to calculate the pH of any of these salt solutions. Okay, so yep, you got it. There's going to be ice tables again. And if you look out the window, my son is waiting patiently to come in, so I guess I better end this video. Thank you very much.